Welcome back to Algebra 2, Chapter 8, Section 2 in this book. Last time we talked about exponential growth, and now we've been talking about exponents. So now we're going to talk about the opposite, exponential decay. And this is not talking about you decaying in the ground or something like that. It's things that don't just go away at an even rate. They increase as they go away. So what we always do is using radiation. Radiation undergoes exponential decay. It goes half is gone, then half of the half, and then half of the half, and then half of the half. So it ends up being that graph that you did in chemistry class or maybe physics. Okay, so we did this in Algebra 1. So this is a decay formula. How much you start with times 1 minus the rate as a decimal raised to the power of time. Because it's 1 minus the rate, it's always less than 1. So is this a growth or a decay? Well, look at that fraction. 3 halves is less than 1, so it's a growth. 2/3, I said the next one. 3 halves is more, I was skipping all the way down to here. Let's do it one step at a time over here. Okay, so this one is 2/3. I was looking at that one and doing the wrong thing and pointing to one and saying the other. Okay, 2/3 is less than 1, so it's a decay. 3 halves is more than 1, so it's a growth. This one looks weird because it has a negative exponent. So we could turn, that's the same thing, negative x is the same thing as negative 1 times x. So we can take that negative 1 and push the 3 through the portal and make it 1/3, leaving the x up here. Now you can see that that is less than 1, so it is a decay. The graph of these things look like that. That's what I do with my hand. Whoop. And so this is the graph of 3 times, that means how much I started with. 1/4 is my decay factor to the x. It would look like that. This one, because it has a -5, and this one looks like that. I want you to do all of these on your calculator. I want you to get your points, your if-then from either table or you can get it from trace. And then I want you to get some points and graph it. Just like a growth, it gets closer to a line without touching it, which is called the asymptote. It's the same formula for the decay as it was for the growth. Just the difference is that base is going to be a fraction less than 1. So here's 1. And just like it has the horizontal and the vertical factor, the shift. The horizontal is the opposite sign. The vertical is the same. So this one is going to go back 2. It's going to go toward the negative on horizontal, back 2. And it's going to go up 1. So if this was my line, the blue one, the whole thing would go back 2 squares and up 1. So I want you to practice all of this on your calculator and graphing it and looking at it and making sure you can do it. Now here's an application problem like what we did in Algebra 1 using this formula. So you bought a car for $24,000 new, and it is depreciating at a rate of 16% a year. You want to know what it's going to be worth after 2 years. So you fill it all in and it will be worth $16,934, which is still too expensive. I'm in the market. I told y'all, or I told one of the classes, I sort of impulsively sold my car. It broke again. I was like, I had it. I'm not fixing it again. And so I ran an ad on Facebook, and a friend of a boy I used to tutor came, and he wanted to buy it. He brought over his mechanic daddy and uncle, and off they went with it. Fixed it for $20. I see it driving all over the place now, and I'm like, ooh, I think I sold my Volkswagen Beetle a little too soon. All right, so I'm in the market for a car, but I can't afford that or that. I'm going to need to look for something about half of that. So these number of years are going to have to go up, higher than 2. All right, maybe at least I can get something in the 2000s. Math is great.